Hello everyone, welcome to Little Einstein. We're going to take a closer look at atoms. All matter is made up of elements that cannot be broken down by chemical activity. Atom is the smallest particle of an element that retains the element's properties. Atoms are the building blocks of everything in this universe, including ourselves. People often think of atoms as the smallest possible form of matter, but even smaller particles make up atoms. Each atom has a dense center called the nucleus. The nucleus contains neutrons which have neutral electric charge and protons which are positively charged. The number of protons in an atom determines the element's physical properties. No two elements have the same number of protons. Revolving around the nucleus, like the planets around the sun, are the negatively charged particles called electrons. Electrons and protons attract each other. Usually, they are equal in number. Scientists ascertain a number to each element based on the number of protons in it, and a unit called AMU, or the atomic mass unit, which is the sum of protons and neutrons present in the nucleus. For instance, a helium atom has 2 protons, so its atomic number is 2. It also has 2 neutrons. Adding number of protons and neutrons, we get 4, which is helium's atomic mass unit. Electrons have almost no mass and are not included in AMU calculations. In an atom, the number of protons remains constant. Individual atoms can lose or gain electrons to form ions. Atoms of the same element can also have extra neutrons. These are called isotopes. Despite having different neutron counts, isotopes retain their elements' chemical properties because the number of protons remains constant. For more such videos, please like and subscribe. Comment the next topic you would like to see on your favorite channel. You can also find more such content on Tuition app.
Let's first know about some history of atom. The term atom comes from Greek word for individual. Individual means unable to be divided. In Greek, the prefix a means not and the word tomos means cut. Our word atom therefore comes from atomos, a Greek word meaning uncuttable. As you know, atom is not indivisible, but it was once people thought that atoms were the smallest thing in the universe and could not be divided. But this is not true. We know that atoms are made up of 3 particles: proton, neutrons and electrons, which are composed of even smaller particles such as quarks. Now let's talk about how atoms are created. Atoms were created after the Big Bang, which happened 13.7 billion years ago. As the hot, dense new universe cooled, conditions become suitable for quarks and electrons to form. Quarks came together to form protons and neutrons, and these particles combined into nuclei. This all took place within the first few minutes of the universe's existence. Now let's know the definition of atom. Atoms are the basic building block of the ordinary matter. Atoms can join together to form molecules, which in turn form most of the objects around you. Now let's know what atoms made of. Atoms are composed of particles called protons, electrons, and neutrons. Protons carry a positive electrical charge, electrons carry a negative electrical charge, and neutrons carry no electrical charge at all. The protons and the neutrons cluster together in the central part of the atom, called the nucleus, and the electrons orbit the nucleus. A particular atom will have the same number of protons and electrons, and the most atoms have at least as many neutrons as protons. Protons and neutrons are heavier than electrons and reside in the nucleus at the center of the atom. So this is the atom's definition. If you like this video, please subscribe us and give us a thumbs up. If you have any question, please do write us in the comment.
Assalamualaikum warahmatullahi wabarakatuh, and good day. Today is our first lesson, topic 1.0 on matter, and today we will discuss on 1.1 atoms and molecules. Okay, so for today's lesson we will discuss on A and B only. Okay, the rest we will discuss on tutorial classes. So today I will discuss on 1.1 and also 1.2. Okay, write the isotopic notation and also interpret the mass spectrum. Okay, so what is a matter? Okay, so matter is anything that has mass and volume. Okay, means anything including living things or non-living things. So if all the what we call it matter or substance or whatever have mass or volume, we can classify as a matter. Okay, for example, okay, solid, non-solid phase. Okay, like what all this gold or whatever, or in liquid phase. Okay, this maybe ink, and also in form of gases. Okay, and matter we can classify into two. One is pure substances and one is mixtures. Okay, and pure substances we can divide into two categories, or elements and also compound. Okay, elements include atoms and molecules. Okay, in atom itself we have subparticles, photon, electron and neutron, that you have learned in your previous at your secondary school, as a secondary education. And also compound, we can divide into ions and also molecules. For mixture, there are two types of mixtures. One is homogeneous mixture and one is a heterogeneous mixture. And mixture, there is a process, physically process, from mixtures to pure substances. Okay, same as compound and elements, there is a chemical process. So there are difference between physical processes and chemical processes. Chemical processes more to chemical reaction. Physical processes is like from solid to liquid, liquid to gas. Okay, it only involve what you call it, state, only the state. Okay, we go to isotope. Okay, what is isotope? Isotope is a two or more atom of the same element but has same proton number, okay, but different in nuclear number. Or we can define isotope is a two or more atom, same element, okay, having same number of proton but differ in number of electron. Okay, before we go through what is isotope is all about, okay, we have to draw the notation of isotope. Okay, for example, atom X, A we call it as a nuclear number. Nuclear number is number of proton and neutron, and Z is a proton number. Proton number is represent the number of electron, and X is symbol as well. So for example, uranium 235. 235 means number of nucleon. Okay, it means that in 235, 235 means sum of proton and neutron. Okay, number of proton and neutron. And 92 is number of electron. Okay, so this is what is proton number. Okay, proton number is number of proton, and number of proton is equal to number of electron for atoms. Okay, and nuclear number is a total number of protons and neutrons. Okay, and nuclear number also called as a mass number. It represents the mass of an atom. For example, chlorine. Chlorine 35, 17. 35 means number of proton plus neutron. 17 means number of proton, and because of chlorine is an atom, number of proton is equal to number of electron. Okay, this is another example. Okay. So these three hydrogen we call it as an isotope. Same element, hydrogen, hydrogen and hydrogen. Same element but difference in number of nucleon or number of neutron. Okay. Okay. Then we go to ion. Okay, so what is the difference between ion and atom? Okay, yes, ion they have charge. Okay, either positive or negative charge. Why they have positive charge and negative charge? That was depend on number of proton and electron. So for ion, number of proton is not equal to number of electron, different. Okay, so the species will exist as an ion. Okay, cation is a positive charge. Positive charge means atom lost one or more electron. Okay, for example, sodium atom lost one electron, it will become sodium ion. So you can see this number of proton and electron are different. So that are the differences between sodium and sodium ion. And for anion is a negative charge. Negative means atom accept or gain one more electron to become an ion. For example, chlorine. When chlorine accept one electron, it will become chloride ion. And you can see here the number of proton and electron are not equal. Okay, so always remember the proton number Z is the nuclear charge and also the number of electrons in the neutral atom of the element. Okay, so proton, if the species are the species are neutral atom, so the proton number and the electron number should be equal. Okay, if number of proton and number of electron are different, it will become ion, either cation or anion. So always remember. Okay, for example, mercury, Hg is mercury, number of nucleon 202, number of proton is 80, number of proton, charge is positive 2, so it means that number of neutron is 202 minus 80, 122, number of neutron. Okay, number of proton is 80, but number of electron is 78. Okay, because positive 2 means lost 2 electron. Okay, so this is an example. Write the appropriate notation for each. Okay, for example, species A, proton. Okay, before that you must identify first either all these species are atom or ion. If you want to know either the species is atom or ion, just look at proton and proton number, electron number. So if the proton number and electron number is equal, so this species should be atom. But if the proton number and electron are not equal, these species are ion, either positive cation or negative ion, and ion depends on which one is higher, either proton or electron. So this is the Okay, we go to the second part, still on 1.1 atoms and molecules. Okay, so in second part, I will discuss on mass spectrum and a little bit about what is mass spectrum. Okay, so this is a mass spectrum. Okay, this is mass spectrum. Okay, so what is mass spectrometer? So mass spectrometer is an analytical instrument used to measure the atomic and molecular masses directly. That means that this device or this equipment or this instrument is used to measure or to weigh what is the exactly what is the mass of atom and mass of molecule. Okay, mass spectrometer is actually atom is a very light and its mass cannot be measured directly. Okay, so the most accurate means for determining the atomic mass is provided by mass spectrometer. So that's why we should have one device or one instrument or one equipment to directly measure atoms and also molecules. Okay, so for mass spectrometer is used to determine, number one is the relative isotopic mass of an atom, because as we discussed earlier, atom has each atom actually exists as an isotope. So we want to identify or we want to determine the exact mass of each atom. Okay, the second one is types of isotope, okay, its abundance, and also relative isotopic mass in the sample of element. Okay, from mass spectrometer also we can identify types of isotope. Okay, abundance mean how many that atom or molecule exists in our environment, and the third one is the relative molecular mass of a compound. Okay, this is a diagrammatic for mass spectrometer. So we have a vaporization chamber here. Okay, so the sample we will put the sample here. Okay, and this is ionization chamber. Okay, to ionize the sample. So this one is acceleration chamber to accelerate the sample or the particle that we want to analyze. Okay, then the sample will go to magnetic field. Okay, at this magnetic field actually the sample can be analyzed and can be separated according to its masses. Okay, then the sample go through to the vacuum pump, and the last one we can identify the relative mass of sample, either the sample is atom or element or compound molecule. Okay. At an analyzer, for example, this is the reading that we will get it at the spectrometer. For example, this is a ferrum, sample of ferrum. At the sample of ferrum, we have 4 types of isotope: ferrum 54, ferrum 55, 56, 57, and 58. So we want to calculate the mass of average ferrum, not for ferrum 54, not ferrum 56, but for ferrum itself. So, okay. So the height is proportional to the amount of each isotope present. So that means for example ferrum 56, isotope ferrum 56, the relative abundance is 91%. That means this one is the most abundant according or compared with other ferrum. Okay, so what are the information that we will get from the spectrum? Number one is the abundance, that represented by the height of each line. the number of peak. Okay, the number of peak means how many isotopes that occur in sample and example. And the most important thing is the ratio of mass, mass, ratio of mass and electron for each species is found from the value of the accelerating voltage associated with the particular peak.
For a sample of chlorine gas, we can estimate that 75% of the atoms would be chlorine-35 and the remaining 25% would be chlorine-37. These different forms of an element are known as isotopes. All isotopes of an element have the same number of protons, but a slightly different number of neutrons. This concept of isotopes was actually discovered using an analytical technique known as mass spectrometry. For chemical research, the pharmaceutical industry, and in forensic science, there are many techniques and tests to identify a synthesized compound or a sample obtained from a crime scene. One crucial technique is calculating the molecular mass of a compound or a sample. This can be done using a mass spectrometer. The beauty of mass spectrometry is that only a very small sample is required. This is important when only a small sample is made or if the evidence is only present in minute amounts. A sample must first be vaporized. Once this is done, the vaporized sample is then bombarded with a beam of electrons. This beam of electrons knocks off electrons from the molecules which make up the sample, creating positively charged ions. This process is known as ionization. The ions formed usually have a +1 or a +2 charge. These ions are then accelerated in an electric field before being deflected by a magnetic field. The pattern of deflection according to charge and mass can then be depicted on a spectrum. The main idea here is that ions with a large mass to charge ratio, meaning a large mass and a small charge, are deflected less than ions with a smaller mass to charge ratio. When this was done using a sample of neon, the resulting pattern of deflection showed that 3 isotopes of neon existed: neon 20, neon 21, and neon 22. The positions of the peaks on the spectrum will tell you the mass of those ions. Besides showing the existence of these isotopes, the isotopic abundance can also be determined from the mass spectrum. The height or the intensity of a given peak tells you the relative abundance. So when a crime scene investigator gives the lab even a small fleck of a white powder, its molecular mass can help identify what it is. In summary, mass spectrometry is an analytical technique used to determine the molecular mass of a compound and indirectly helped to prove the existence of isotopes.
Okay class, please answer this question for exercise 2. Okay, give you another 5 minutes to solve this question. Okay, good luck. Okay, we go to the last part for today's lectures is for 1.2 on mole concept. Okay, for learning outcomes, so today for this part I will discuss on the A on define the terms of empirical and molecular formula. B and C we will discuss on the tutorial classes, and D we will discuss for the next class after this. Okay. Okay, what is a chemical formula? Chemical formula is empirical and molecular formula. Empirical is the simplest ratio of element in the molecule, and for molecular formula is the exact or actual number of atoms for each element in the molecule. For example, water H2O. Okay, so for H2O, the actual number of hydrogen atom for one water molecule is the exact number of hydrogen atom in one molecule water is 2, and the number of oxygen atom in water molecule is 1. And because H2O is the simplest ratio, so the empirical and molecular formula for water is same or equal. The second one is glucose. This is glucose. In glucose we have 6. In one molecule of glucose we have 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. And for simplest ratio for C6H12O6 will become CH2O. So this is an empirical formula for glucose. For N2H4 is a hydrazine, is a base form compound. Okay, so this is the actual number of atom exists in hydrazine, and the simplest ratio is NH2. So that is the differences between empirical formula and molecular formula. So the relationship between empirical and molecular formula is like this. Molecular formula is N of empirical formula. So for water, the number of N is equal to 1. For glucose, the N is equal to 2, and same as hydrazine, the N is equal to 2. Okay, this is an exercise. Which one is the empirical formula? Okay, so to determine which one is empirical formula, you can see the simplest ratio. Which one is the simplest ratio? Okay, for example, C2H4. C2H4 is not a simplest ratio because the simplest ratio for C2H4 is become CH2. So this one is not a empirical formula. This is a molecular formula. Okay, please do the exercise 2. Okay, I give you 2 minutes to solve this question. Okay, class, this is the end of this lecture. So see you next. Okay, thank you. See you.